In previous lessons, we have mentioned that the key for successful data visualization is the correct communication of a message. So now let's see how this process works. So let's say that you have a dataset that you have explored and analyzed, and you have arrived to some conclusion. That conclusion, for example, is that the value of something is increasing exponentially. And this is the message that you want to transmit. So you come up with some sort of visualization to apply to your dataset so that it transmits the message that you have discovered. So now you're happy about your visualization and you might think your work is done. But no, this is actually only the first part of the communication process. The second part starts when the user sees the visualization. Then the user will take a look at this visualization and will try to understand what is the message that the graph is transmitting. So your goal is that the user extracts the same conclusion you arrived to when you analyzed your data. In this example, you want the user to understand that something is increasing exponentially. But more often than not, the user will arrive to some different conclusion. Maybe because he's distracted by the choice of colors or shapes, our user has arrived to a different conclusion. That's because we need to take into account that the communication process is divided in two stages. The first one is the one where you take your data and the message you want to transmit and you turn it into a visualization. And this part is called the encoding part. The second part, the decoding, which is equally as important, takes place when your audience looks at your graph and tries to extract information from it. So we, as data visualization designers, we need to put a lot of effort into making sure that the decoding part of the communication process works. So, as William S. Cleveland said in his book, The Elements of Graphing Data, no matter how clever the choice of information and no matter how technologically impressive the encoding, a visualization fails if the decoding fails. So, how can we make sure that the decoding doesn't fail? Well, the key is that we need to speak in our audience language. So, we need to analyze what is the most natural way to decode information and then design the graph accordingly. For example, let's say that I am communicating with a friend who is an English speaker and I want to write him a postcard, so a written message. What language am I going to use? Spanish? Chinese? No, I'm going to write it in English because that's the language that my friend understands. So, when we try to transmit something in visual language, we need to encode our message using the visual language that we know that the audience will understand. But how do I know what does my audience understand in terms of visual language? Well, luckily, there's a paper by two scientists called Cleveland and McGill, which is from the 80s, called Graphical Perception, Theory, Experimentation, and Application to the Development of Graphical Methods. In this paper, the authors study the details of the decoding part so that we can design more effective encodings. So basically what the authors are doing in this paper is bringing some science into data visualization through the study of human graphical perception. And they have three goals in this paper. The first one is to identify the essential perceptual tasks that are carried out when people extract quantitative information from graphs. Let me show you this with an example. When you look at a plot like this one, which is a simple scatter plot, what you are unconsciously trying to do is to compare the position of the dots along the vertical and horizontal axis. So basically, the information of this graph is encoded in the positions where the dots lie. However, if I show you a graph like this one, which is something called a bubble plot, you will need to pay attention to the position of the circles, as you did before, but also you will need to take a look at the areas, because here the areas of the circles are representing some information as well. So these two tasks, decoding position and decoding area, are part of the 10 elementary perceptual tasks that the authors found that are the basic tasks that we do when extracting information from a graph. The second goal of this work is to produce a ranking. So once we have identified the 10 elementary perceptual tasks, our question is, how do they compare against each other? Is it equally difficult to compare position and comparing area, for instance? So what they want to do is to produce an ordering of the tasks on the basis of how accurately people perform them. Generally, when a user is decoding the information in a graph, the user will have to perform one or more of these elementary tasks. The thing is, some of these tasks are easier to perform than others, and some of these tasks yield to more accurate perceptions of the numerical quantities depicted. And what do I mean by accurate? Well, to know if a task is accurate or not, we need to compare the perception of the user with the real data. In other words, we need to compare the numerical quantities that the user thinks are being represented in the graph versus the real quantities of the data. If the user gets close to the real values, so if the user's guess is close to the real value of the data, that means that the task is accurate. If not, the task is not as accurate. And by doing experiments like this, using the different tasks, the authors of the paper were able to produce a ranking of the elementary perceptual tasks. And what are we going to do with this? Well, once we have a ranking of the elementary perceptual tasks, we will be able to redesign old graphical forms and design new ones. And as the author said, the goal is to construct a graph that uses tasks as high in the ranking as possible, meaning that we will favor those tasks that yield to more accurate results. And according to the authors, if we apply this to the current charts, so the charts that we use every day, a bar plot, a pie chart, and so on, radical surgery on these popular types of graphs is needed. And when we start to redesign these graphical forms, we will see that graphs that require to do a simpler task, so a task higher in the ranking, will be graphs that are easier to read and interpret than graphs requiring a difficult task. And also that graphs that require to do several tasks will be more difficult to interpret than those that require fewer tasks. And with this, the authors hope that we will be able to redesign the traditional plots to simpler, more effective ones. So, in the next lesson, we will start by defining which are the 10 elementary perceptual tasks.